Hey guys, welcome to another Python video. In this video we're gonna talk about files. In the previous video we covered exceptions, and let's dive into the files. I will show you some examples in Visual Studio Code. So as we look into these file, we can see examples how to use Python to open and close files. Now, when I will talk about files, I mean any file, not just the txt file or .py file, okay? So feel free to experiment with any kind of file. Before we move on, let's define what a file is. So each of the file consists of header, data, and end of a file. End of a file is a special sign or character which represents the end of the file. This helps Python while reading the file to stop the reading after seeing the end of the file sign. Now files are stored at the path, and the path differs across Windows and Unix. So Windows guys, please beware that always I'm writing the path in the macOS, which is a Unix based file system. So in case of Windows, please make sure you know the exact path to the file. Now the next thing is that files have lines, and each line according to standard can end either with two signs called carriage return and line feed in case of Windows, or it can just end with a line feed in case of Linux based operating systems. Now we already encountered the line feed when we had the new line sign in the print statement. The front slash .n sign is exactly the line feed sign which is in every file in the macOS or in the Linux. Now in case of a Windows, you will encounter signs like /n or /r/n at the end of the line. These carriage return line feed combinations can many times cause troubles while moving the files from Windows up to the Mac. So please beware of this fact. Now, in order to read from file, we need to open and close it. And in Python, when you want to open a file, there is a built-in function called open, which consists of one necessary argument, which is the name of the file or the path to the file. Now here, when I'm calling file render variable and I'm setting it to open datafile.txt, I'm setting it to an object of the file, which is returned by opening this file. Now the question can be, okay Michal, but where does this file resides? Well, whenever you run a Python interpreter or a Python code, a Python will always look for the files within the root directory. And now the root directory in this case is the Python folder here in the left in the Visual Studio Code where the Python file resides. So data file txt will be looked for here within the folder. Okay, so if I will move the files.py file into another folder and I will run it again, and the data underscore file txt won't resides there, this can cause troubles or can misbehave. Okay, so beware that you always need to place the files next to your Python script. Now, whenever you open a file in the Python, you always need to close the file. Now, this is a very good example in practice. When you don't close the file, this will cause a lot of troubles. Pending open files can cause memory issues with your computer while running the Python code. So please, always, after running the open, always run the close on the object which is assigned to the variable. Now, I know that I didn't talk about objects too much. Just keep in mind, whenever you run an open, this will return a file object. I can show you in the next examples. Now, because many times people forget to close the file, one thing is highly recommended in Python, and that's the usage of something which is called Python Manager. And wherever you will see a keyword called with and then followed by anything, this is something which is called manager. Now the Python Manager will run the command which is followed after the with and assign the value, the return value of the command to the variable which is after s. So basically this one line of code is exactly the same as this one. Now, and the Python managers are a very powerful tool. Here, whatever you open within the Python manager with open will be closed after the indentation block of the manager. So after the body of the manager is run, the file will be closed for you. You don't need to call the file.close, okay? So this makes our life a little bit easier, and we can concentrate on other stuff while coding, okay? So let's run this, and you will see that after I run this, I will see, sorry, you need to first run the Python interpreter in your terminal. So please type down Python 3 in case of macOS. Then highlight the code and shift enter. Again, 3 dots, go there, click in the terminal and press enter. And you can see these strange brackets and the things inside refers to an object. And we can see that there is something which is called text.io wrapper, which is returned after we open the file. Now, many of you may notice that besides one required argument, there is another optional argument, which in this case is an R. So the R letter in this case stands for reading. So in this case, we are opening the data underscore file.txt only for reading. You can open the files also for many different activities. For example, you can open the files with W for writing, yes. Then you can open the files with RB, which stands for reading binary. Now, reading binary is very special kind of reading, which is used mostly with picture files or another data types. Now, in this course, I'm not covering the read binary or write binary functions or modes while reading the file. So please feel free to Google it. I will not use it during the data science courses. So if you are interested in it, you can find many of resources at the Google. Now, besides reading and writing, there is one more thing. It's called appending. Whenever you open a file for writing, it will rewrite the content of the file. But if you want just to append something at the end of the file, please run the open file with the A, which stands for append. I will show you examples later in this video. So now let's go back to our example and open the file called data underscore file.txt for reading and assign it to a variable of file. Now, if you look here, I have the folder structure which I'm using, and as you can see, there is the GitHub repository which you can find the link in the description below. But here in the repository, you can see that there is a files.py, which is the file which I have currently opened. And now in the same level in the directory, you can see the data underscore file over here. Click here and you can see there are just numbers printed on each line. So this is a txt file. Feel free to open it in any other editor if you want, but Visual Studio Code is able to open almost every file. So, and you know that it's not the .py file because it ends with txt suffix. So let's go back to files and open this file. And as you can see on the next line, line 14, I'm running a command called print, which is basic print. And after that, I'm calling a function upon the file object, which is called the read line. And now read line expects one optional argument, which stands for how many signs I want to read from the file. So in this case, I want to print just the first sign of the file. And if you look into the file, the first sign is number 4. So if I run this command, so now I'm running on the only first line, and I'm reading the first sign of the file, and it's 4, and the 4 has been outputted to the output. Now let's say we want to run the same command, but reading in this case 2 signs. Now the question for you is, what will be the output in this case? I give you time. Yeah, and those of you who said that the 4 sign and the new line will be outputted are correct. Now, why is it this? So let's just run the command first. So as you can see, the 4 has been outputted, then the new line has been outputted, and then again the new line. Now, the 4 has been outputted because of the file.readline.1, and because we put it into the print out of the box, optionally automatically put a new line after the print, right? So that's the reason for the first new line after here, right? But then, because the file doesn't only consist of the visible signs, there are also invisible signs, each of the line, as I said at the beginning, is ended with a line feed sign. Now this line feed is the new line for the print statement, and that means that the print statement will print the line feed because I'm printing the second character, and in this the second character is the line feed. And because I put the line feed into the print print out of the box puts another new line after the line feed. And that's the reason why we ended up with so many new lines after the for. Please take your time, pause the video and try to think about it. Yes, line feed is at the end of the Unix files, and now we are in the Unix, in the Mac OS, so Unix-based file system, and that's the reason why the line feed is there. Now, what if I read first 4 characters and just try to run this code on your own and try to check out the code? I won't do it right now. Now, besides reading the file one by one, the signs from the file, or the characters from the file, you can read everything at the same time. Now, by opening the data files that are like this and calling the function called readlines, this will return, as you can see, a list of lines. And as you can see, for the first line we have the for and the line feed. For the second line we have 5 and the line feed, and so on and so on. So those are the line feeds, as I mentioned in the last examples, right? So these read line S, not read line as previously, return the array of, or the list of these strings. Now then you can iterate in the for cycle through this and output it. So I added the ending, I override the out of the box ending of new line for the print, and I put there empty sign, not to output everything on the new line, right? Because then I would have this 4 new line, 4, 5 new line, and so on. So in this case, everything will be outputted as it is in the file. Amazing. Now, besides reading from the file, you can also write to the file. Now imagine we want to open a new data file that for writing as file. Now I have the data file over here, new data file over here. So I will just delete it for you, move to trash. And as you can see, if the file doesn't exist, Python will create a new file for us. Yes, so in this example, I'm opening a new data file for writing, put it to variable of file, and then I'm iterating through list of strings, and for each string, I'm writing it to a file. Now this is fairly easy. My question to you is, what will be the output? And if I run it, right, these numbers stands for the number of signs within each word I'm writing to a file. So 6 is here because Michal consists of 6 letters, Hutsko consists of 5 letters, that's the 5, it has 2 letters, and so on and so on. So now, as you can see, a new data file has been created. If you remember, I deleted the file before, now it's here. The question for you, what will be the content of the file? And those of you who said Michal Hutsko is a good teacher are correct, but there will be no spaces in this case, because I didn't provide any spaces to putting into the file, right? Feel free to try this example and try to put there the spaces into the file if you know how, okay? Now, let's imagine we have a simple task. We want to open a data file and write it backwards to backwards data.file. Now there are 2 things. One thing is how to write a file in backwards, and second, how to write a file which is not the .txt file. Now the second one is very easy, but we will start with the first one. So first of all, you need to know one crucial thing. Whatever is defined in the Python manager is accessible outside of the scope of the Python manager. What does it mean? In previously, when we specified some variable in the function, it was not accessible outside of the function. But this time it is different. When we open the data_txt.rs file and then we assign to a data the content of the file by using the read line, so in this case it will be the array, the data will be accessible outside of it. Right? So beware of the fact that the Python contexts are not the functions, like the body of the Python manager is not the body of the function, and that means that the data is accessible from outside. So this is 100% valid. And because we have this, we are able to use the data variable in another Python context. So in the first Python context, Python manager context, we read a file, and in another we will write to a file which is called backwards data files.py. For write. Now as you can see, because I want to write to a Python file, the only thing I need to change in definition of the Python context in the Python manager is the suffix. So in this case it's .5 instead of txt. Amazing. Now, having the data, we can call the built-in function called reversed. So the reversed function in this case will reverse the order of the list. So let me just write to you both of them. Reversed data. And if I run these two commands, you will see that in the first case, we have the correct list, and in the second case we have again some object, right? And because reversed is returning an object, in order to see the output you need to put it to list, okay? Yeah, it's the same practice and example as with the enumerate. So the enumerate object, and this is a list reverse iterator. Well, that's a complicated name. Reverse iterator object. So please put it into the list, and then you can see the list is reversed in the another variable, right? So that's why we can rewrite it backwards like this. So we can run it, and as you can see when I open 2, because everything is the size of 2, because in the data file there were these 2, but because there was the new line feed, it is another extra character, so that's the reason why it's 2. So now if I open backwards data files.py, I can see it's in the reversed order. Amazing. Now let's go next. The last thing I want to show you, well, there are two things I want to show you, is how you can append to a file. Now imagine you have the file which I already created. It's called backwards data file.py, and we want to append to this file two numbers, 10 and 9. Now, how to do it? Well, it's quite simple. You go and use the built-in open function and add their number, letter A, just to append to the file, and we will now append to the end. And now we want to add their 10 and 9 in a list. So iterate through a list and assign it to a variable number, and we can just write it down. But the thing is, like, this is a little bit tricky. When I run this, what will be the exact output? What will be in the backwards data underscore file.py? So those who said that there won't be any new lines were correct, right? Because I didn't specify the new line, everything is put one after another. So in order to fix this, you can, for example, do it many ways, but this is one of the ways. So you can add here a line feed sign. So when I run this command again, I go here, as you can see, because I'm appending, I'm adjusting the old file, so the previous 10 and 9, one after another, stayed there. So then the 10 was printed here and 9 was here. So if I want to make it 100% correct, I delete this, save the file, and then I run this, enter, and if I look back here, it's 10 and 9 correctly written at the end of the file. Amazing. I hope you understand this simple example of appending, and feel free to experiment on your own. Now the one last thing I want to say, you don't have to work with the files on the same level as the Python file is. You can access to the tree directory of the file, so of the folder where the Python file resides. So for example, imagine you have the file folder at the same level as the Python file is, and you want to write to a file to read from the file which is in this folder. And then you can specify the way how to traverse the tree, the folder tree, to get into the file. So in this case, I'm going to the file folder and opening the data files.txt and reading it. And that's basically the same example which I did, but let me just paste it. It's 45321, and if I go into this file, it's this file, right? So it was simple, but the thing I want to tell you is, like, beware the fact when you are using Windows, the path, the specification of the path may differ. So for example, you can specify the absolute path there. You don't have to only to stay in the tree directory of the current folder. You can go to the parent folder like this, using two dots, and then you can open a file which is in the parent directory of the folder where the actual Py file resides, right? But if you want to specify a full path in the macOS, this is 100 valid. So from the home directory of your machine, you're gonna open the Py file. But beware the fact that in the Windows it's a little bit different. Okay. Now, yes, I talk too much about files and folders, and maybe some of you don't know what is the Unix-based file system and stuff like this. Don't worry. In the next videos, where we will cover some bash basics, and well, it will be in next tutorial, and where we will cover how to handle basic file structures in the Unix machines, in Unix-based file systems, which is macOS, for example. We will cover these details, so now feel free just to understand how the open in the Python works. Now, to be honest, in most of our examples we won't use the open file because the frameworks and the libraries which we will use do some kind of black magic behind the scenes with this open for us, so we don't need to worry about opening and closing the files. But I wanted to cover this topic because it's one of the essential Python skills you need to have in order to work with the files. Okay guys, I hope you enjoyed this video, and I hope I will see you in the next one.